I ran a curl command on our app once. One address. It answered. Handled by Server 7. Server 7? How many of us are back there? And how did I land on exactly one?
You knocked on the front door. Something behind it picked a server for you.
I didn't pick anything. I typed one address.
Right, and people explain it away with, Nginx sits in front of your app. That explains nothing. Nobody tells you what in front actually does. So today, we open the door. By the end, you'll know exactly what stands in front of your app, and the one thing it does that logs you out for no reason. This is Sticks It Out.
Front desk of doom.
Last video, an orchestrator kept 10 identical copies of your app alive. Remember them?
Yes, the agents on the phones. I killed one. It came back. Haunted.
Those 10 are still back there. But a user types one address and gets one answer. So who stands at the door and hands each visitor to one of the 10? That's a load balancer. A load balancer is one front desk in front of many identical copies. Every request hits the desk first.
Why a desk? Just give everyone the address of a server and let them walk straight in.
Then you'd hand 10,000 strangers the private network address of every machine you own. As we go, we'll watch that idea die. Here's the desk, the copies, and you. It makes 4 decisions before you ever reach a clerk, and the last one is why you get thrown out mid-checkout. Start simple. A visitor walks in. Which of the 10 clerks handles them?
Always the first one. He's right there.
So every visitor goes to clerk 1. Clerk 1 is buried. The other 9 clerks read the newspaper.
Okay, that's bad.
So the front desk goes down the line. Visitor 1 to clerk 1, visitor 2 to clerk 2, and around again. That's round robin.
Take turns. Even I do that.
But turns are dumb about length. One visitor needs 5 seconds. The next needs 5 minutes. So a smarter front desk watches who's actually busy and sends the next visitor to whoever has the fewest people. That's least connections.
So it just counts heads at each clerk.
Roughly, yes. Spread the load so no single copy drowns while the others nap. So it spreads people evenly. But spread assumes every request is the same size. How does the desk even know what you're asking for? Good question. Some desks can't read what you want and some can't.
How can a desk not read?
Depends how smart it is. A layer 4 desk is fast but blind. It reads only the outside of the envelope, the IP address and port, and shoves it to the next clerk. It can't tell a one-word question from a huge video upload. It just moves connections.
I respect the apathy. Just pass the buck.
It's lightning fast. But a layer 7 desk opens the envelope and reads the letter. See a request for the /images folder, and it routes you to a clerk who only handles images.
Reading my mail. Creepy.
It's application-aware routing. It's how an API gateway splits traffic across microservices. Now the desk picks smartly. But what if it sends you to a clerk who already went home? A copy crashes. Or the machine under it just stops. The clerk's chair is empty.
So the desk sends the next visitor to the empty chair. Classic.
Only if the desk is blind. A good front desk checks. Every few seconds it pokes each clerk. You there? Still working?
And if a clerk doesn't answer?
The desk crosses them off. No new visitors go to a chair that went quiet. That's a health check.
Wait, the orchestrator from last video already did that. It refilled dead agents.
Different job. The orchestrator keeps 10 alive from the inside. The front desk decides who to trust from the outside, right now. A copy can be running, but stuck in a loop, refusing to answer the door. The desk only routes to the ones passing its check, so it always finds a living clerk. Then why did you get logged out halfway through checkout? You log in. The desk sends you to Clerk 4. Clerk 4 remembers you.
Good. Clerk 4 is my guy now.
Next click, the desk sends you to Clerk 9. Clerk 9 has never seen you.
Clerk 9, it's me. We logged in together.
You logged in with Clerk 4. Clerk 9 wasn't there. So the app throws you out.
That's insane. Why doesn't Clerk 9 just know?
Because the copies don't share a memory. Each one only knows its own visitors. 2 fixes. 1. The desk pins you to Clerk 4 every time. A sticky session.
Sticky, so my guy stays my guy.
Yes, until Clerk 4's machine catches fire, and your session dies with him. So the better fix, put the memory outside the clerks. One blazing fast shared notebook every clerk reads from, usually an in-memory database like Redis.
So if Clerk 4 burns down,
Clerk 9 reads the Redis note. Your session doesn't even blink, and the copies stay completely interchangeable. So one front desk reads envelopes, spreads load, skips dead clerks, and keeps you logged in. That's a lot for a router. What else is it hiding? Here's the twist. That front desk was never just picking clerks. It also checks your ID at the door. It unwraps the HTTPS lock so each clerk doesn't have to waste time doing the math. That's TLS termination.
So the clerks stop doing security theater.
And when 100 people ask the exact same question, the desk keeps the answer on a sticky note and hands it out without bothering a clerk. That's caching.
A desk that answers for them. Lazy, I respect it.
One public door, many hidden offices, and you never learn a single clerk's real address. A front desk like that has a name. It's a reverse proxy.
So load balancer and reverse proxy are
The same desk wearing different hats. Load balancing is one hat. Nginx is the famous program that wears them. And in Nginx, it's almost boring. You list your copies in an upstream block. Then one line, proxy pass, means hand this request to that group. That's the whole spell. In front of your app is a list of servers and one instruction to pass the request along. Whole thing on one screen. Your request hits one front desk, a reverse proxy. It opens the envelope, picks a healthy copy, spreads the load, leans on Redis to keep you logged in, ends your encryption, and caches the boring stuff. This week, look at your own setup. 10,000 users hit one address. What stands at the door? Because here's the part that bites people. You put a load balancer in front of your app so no single clerk is the weak point. But now every request on Earth goes through that one desk. The desk is the new weak point, and you can't load balance your way out of it. A balancer in front of the balancer just moves the problem one step. So real sites run two desks, sharing one floating address. But they don't split the work. It's active-passive failover. One desk does everything. The second just stands there, staring at the first, waiting for it to drop dead.
brutal.
The second it dies, the passive desk grabs the floating address and takes over instantly.
So I put an active passive desk in front of my active passive desk, and another in front of that. Forever. Unkillable.
That's not... You'd have infinite front desks and zero clerks. Please don't. One thing we skipped. How does one address even find that floating front desk in the first place? That's DNS. This has been Sticks It Out. Don't let your brain deploy on a Friday.